Solve the following system of equations. If there is a single solution, answer it as an ordered pair, x, y. If there are infinitely many solutions, parameterize your solutions in the form of a point x, f of x. Answer using reduced fractions if necessary. Okay, so any system of equations that we come across, we won't know ahead of time if there's a solution, no solution, or infinitely many solutions. So we just have to assume at first that there is, and then we'll prove along the way while we're solving if there isn't one later. Now, this is a small system. We have two equations and two variables. The best choice for a linear small system is the elimination method. It's usually the fastest. So that's what I'll do. So to use the elimination method, what I need to do is multiply one equation by some value so that when I add it to the other equation, a variable will cancel out. So I'm going to take the top equation and multiply that by -1. So that would give me -4x plus y equals -9. Then I'm going to add that to the equation 4x minus 3y equals 3, because when I add -4x and +4x, those cancel each other out. Y minus 3y is -2y. -9 plus 3 is -6. And if I divide both sides by -2, I'll come up with the value of the y. So that's 3. Now, knowing the value of the y-coordinate of the solution is almost done, but I also need to know now what the x-coordinate is. At this point, I know for certain that there is one solution, so I have two lines that intersect at a single point. Some other things would have happened if there were no solution. For instance, your variables all end up canceling out and you get something equal to a constant if there's no solution. Or possibly, if there's infinitely many, everything cancels out. But here, I got an answer, so I know there's one solution. I just need to figure out what the x value is. To come up with the x value, I just take this point and plug it into either equation now. It doesn't really matter because it solves both in the same way. So 4x minus 3, that y value I just came up with, and I'm just using the top equation here, should be equal to 9. So if I add 3 to both sides, that leaves me 4x equals 12. And then if I divide both sides by 4, I determine that the x-coordinate of this solution is 3. So my solution here as an ordered pair is 3, 3.